Now, while we are going through the handwritten solution here, I would actually suggest that you please start making notes along with me if you haven't done it so far. Okay, so very humble request. Now here we'll focus more on the physical side of the graph here. Of course, a little bit of the mathematical parts as well. So the graph one has positive y, positive x, negative x, and we have a graph that starts below the origin. As you're thinking right now, this is exactly how we will be reading every graph based question hereafter. Understanding what is the y-axis, the x-axis, and then to read and interpret the graph. Okay. Now, since the y-axis is phase and the x-axis here is time, the graph originating below the origin along the phase, it means the phase is starting from a negative value here, and it is linearly increasing phase. Okay. Now, as a note here, see, I'm assuming that most of us who are here are beginning your class 11 curriculum with this question for your 2026 practice or 2027 practice. Now, I'm not trying to take you through many different topics which you haven't started yet and trying to overburden you with it. No, I'm just trying to tell you that every question in the JEE mains, for that matter, any exam related to the class 12th, the entrance exam series, particularly to JEE mains, the questions asked this year, 2025, this will be very relevant as a base for the questions for next year. I hope that makes sense. Okay, which means each and every question itself is a potential question as a similar question recurring the next year, or the options within a question can be an indirect indication of a similar question based out of that option. And that is the reason why we explore every option. See, of course, not all numerical options. Say for example, if you have four different options in a question, minus 2.0, minus 2.1.0, or maybe minus 2.1.3, things like that, we never go through the options then. But when the problem statement given in the options has a physics to it, or has a possible angle of physics to it, we will have to explore it. That's why that justifies the detailing of every graph here. It's not that I'm trying to spend an hour for a question that could be solved otherwise, could be explained otherwise in 5 minutes. No, the purpose is to make sure that you just don't get the answer correct, but rather you understand the physics behind it, and of course make yourself better prepared for a question based out of that. Okay. So let us write this down and read this along with while we are watching it. So x of t is equal to a times sine omega t plus phi 0. I'm pretty sure you will now be able to recall what this is. X here is, yes, based on your class 10th oscillations, we have x of t is displacement, a here is amplitude, and sine omega t plus phi 0 is what we call as the instantaneous phase. Even though x of t can oscillate, sine omega t plus phi 0 can keep on either increasing or decreasing. This is similar to angle traced by a particle executing circular motion. Particle oscillates between 2 points, but the overall angle increases. What does this mean? This means that the particle is actually restricted between negative a and plus a, say over a simple pendulum here, but the overall angle theta that is executed measured from the mean point, it will keep on increasing. I'm deliberately not giving you explanations in detail because I just want you to have, a superficial, a touch of the superficial concepts in the chapter. To put it in simple words, I would say I just want you to get acquainted with these words. Don't go much in detail. Just be acquainted with the concepts mentioned here. These, getting this acquaintance will help you a lot when you do questions in the coming chapters. Okay, so tiny bits of pieces here and there, and then purely like a puzzle. And when we complete the fourth and fifth chapter, you'll be like, wow, all those puzzles would start completing, start solving on their own, and make a very clear picture. Okay, right. Now phase is actually, it has two components here: omega t plus phi and phi zero. Now theta is equal to omega t plus phi. When I say theta, I mean the argument of sine here, which is argument of a sine theta here. So theta is omega t plus phi, and we have another term which is phi zero. Both of them are usually represented by the same word phase, which actually creates a bit of a tiny bit of confusion, I would say. Now we need to understand what it actually means. When we say theta is equal to omega t plus phi, we are referring to the instantaneous phase, which means phase at a particular instant of time, general instant of time. And omega t within this comes from passage of time, which means as time increases, omega t increases as well. Or if the value of omega is decreasing as time increases, omega t would decrease as well. That depends upon whether omega is increasing or decreasing. Okay. Now, phase phi zero is actually the initial phase. Is the initial phase. It comes from the initial conditions. It depends on the initial position. It depends on the initial velocity and direction of motion. Okay. Now, if I had to give you an analogy with this, the instantaneous phase is like the marks you score for your practice test for class 11th topics: motion in a straight line, motion in a plane, loss of motion, work energy power, gravitation, rotational motion, things like that. Initial phase is the marks that you have scored in your class 10th that you start the program with. Okay. And the concepts, your strength of your concept at that level. Hope that makes sense. Now, omega t, it relates how much the clock hand has moved since we started the motion. Okay. Theta, where the clock, theta represents where the clock hand already was when we started watching. My bad, this is not theta, this is phi zero. When we started watching phi zero, how much the clock hand has moved since we started motion, omega t, or we since, I think it's a better word, we since we started watching the motion. Okay. Now, y axis is phase, x axis is time, y here is equal to theta, which is the instantaneous phase, and this instantaneous phase theta is written as omega t plus phi zero, which means we're actually writing this as, compared to the equation, y is equal to m into x plus c. Then we have theta is equal to y. Y is the phase. X is equal to t. X is time. And c is phi 0. Okay. So let's just compare this one more time. Y is equal to mx plus c, right? Theta is y. X is t. And therefore, what is m? M is omega. And what is c? C is phi 0. What is omega? Omega is the angular frequency of the motion. So the gradient of this line, the gradient of the curve is omega. And what would that mean? So say this is theta 1 and this is theta 2. It's very clear that theta 1 is less than theta 2, which would actually mean tan theta 1 is less than tan theta 2, which means slope of the first graph is less than slope of the second graph. Less slope or gentler slope means omega is small, which means the oscillation is smaller. Sorry, the oscillation is slower. M2 is the slope 2, which means the slope is steeper, omega is large, and therefore the oscillations are happening faster. Say from t is equal to 1 to t is equal to 2 seconds. The bob was here, it made up till here, and it moves all the way back to this. So it's started from O, it moves to A and comes to minus A. But during the same time, t is equal to 1 to t is equal to 2 seconds. The bob started its position here, it moved here, it traveled all the way back, it traveled all the way back again, and it traveled one more time. This would make it faster oscillation. Okay. Now we need to understand what does this actually make a difference in the mathematical angle. Omega if is equal to pi radians per second. For example, if t is 1 second, if the initial phase is pi seconds, if the initial phase is pi radians, I'm assuming here that when we started the observation, initial phase phi 0 is 0 radians. Then we have t is equal to 1 seconds, phi is equal to pi. And if the angular frequency is pi rad per second, then phi will be equal to pi. At t is equal to 2 seconds, it will further increase by a value of pi, which makes the instantaneous phase at that point equal to 2 pi. At t is equal to 3 seconds, another pi is added, which makes it 2 pi plus pi, 3 pi. Okay. Almost analogous to say v is equal to u plus at, right? To summarize this, phase versus time, theta is equal to omega t plus phi 0. This point here is phi 0. At t is equal to 0, so if you substitute the value of t is equal to 0 in this equation, omega t becomes 0, omega t is 0, omega times 0 is 0. So this becomes omega 0, theta is equal to 0 plus phi 0, which actually is phi 0. So what is phi 0? Phi 0 is the value of theta at t is equal to 0. In this axis, which is the y-axis, what is the value of x? The value of x is equal to 0. What is x? X is t. So when t is equal to 0, the value of y is what we call as phi 0. Okay. Now let's just try to visualize instantaneous phase one more time. We know theta is equal to instantaneous phase and x of t is equal to a sine omega t plus phi or a sine theta. If phi is equal to 0 and if t is equal to 0, say phi is equal to 0 and t is equal to 0, which means we're going to make these two values as 0 here, right? These two values of 0. That's a minor mistake here. My bad. This means this expression is equal to a sine. What is t? T is 0. What is phi? Phi is 0. Sine of 0 plus 0, which is sine 0. What is sine 0? Sine 0 is 0. So that becomes 8 times 0, which is equal to 0, which means the pendulum is now at x is equal to 0. Now you're like, okay, 50-50. But we're going to make it to 50, 100, right? Okay, let's do that. Now, x of t is equal to a sine omega t plus phi. Phi is pi by 2. Time is 0. So this transforms to sine t is 0. So that becomes 0 sine of 0 plus pi by 2. 8 times sine of 0 plus pi by 2, which is equal to 8 times sine pi by 2. And what is sine pi by 2? It is 1. So that is equal to a. Which means in this figure, maybe you can place it like this so that you understand that the motion, right? Yeah. So it actually means that the object is on its path like this. Okay. Now, some of us might be having a question here as soon as I say towards its path like this. And what would the question be? Okay, let's look at that in a while. Now, if time is equal to 0 and phi is minus pi by 2. Oh, my bad. My bad. My bad. I was trying to trick you. Instead, I got tricked myself. This is wrong. Please, if you have made note of that part that I've mentioned here, please erase it out. Okay. I was trying to say when t is equal to 0, when we started observing the motion, it was at this point, a is equal to x. Now, when we started observing the motion, it is t is equal to 0 here. And phi is equal to minus pi by 2, say. So that mean it would mean that a is equal to, sorry, x is equal to a times sine a times sine omega t 0 omega into 0 plus phi, which is minus pi by 2, which gives you 8 times sine minus pi by 2. Sine minus theta is minus sine theta, which is 8 times minus sine pi by 2. Sine pi by 2 is 1, so this is minus a, which means while we started to observe the motion, the bob was not in these positions. It was rather at x equal to minus a. Okay. Now the question, What can we infer from this value? If phi is equal to pi, let me just write it down for you. This would be a times sine omega into 0 plus pi, which is a times sine omega into 0 is 0 sine pi. Sine pi is minus 1 raised to n, which is minus 1 raised to 1, which also gives us minus a. Oh, sorry. Cos n pi is minus 1 raised to n. Sine n pi is 0. My bad. So this gives you 0 again, right? This gives you 0. So x of t here is again equal to, x of t is equal to 0. Okay, so the whole point of this drawing the graph was to explain that at t is equal to 0, if theta is equal to phi 0, which is a negative value, it actually means that the object is already in motion. Or, in other words, the motion has started even before we actually started the observation. Okay, it's very hard to make sense out of the pendulum experiment here unless we watch it as an animation, which is something that we will do in detail in simple harmonic motion, not here. However, if you wanted to visualize things, let me just give you a very simple example here. We know that time is equal to 0. Time is equal to 0 actually means not when the motion started. Time is equal to 0 means when the observation started, right? So start of observation is actually what makes t is equal to 0 and not the beginning of actual motion in itself. Okay. Likewise, phi 0 is the phase of the motion corresponding to t is equal to 0. And swing was already in motion. It was in the main position. Somebody pulled it and released it. It went. Okay, I don't know how to figure this out. I hope that makes sense. It was swinging around like this, left extreme, right extreme, to and fro. Okay. Now, while this is happening, we started observing the motion when it was at this position. Say, position, this is A, B, C, and D. Now, what is the well, what was the actual position when the motion started? The actual position when the motion started was like this. The swing was actually like this. But when we started observation, it was already in the left extreme. Okay. So in this case, at t is equal to 0, phase is already negative. It means the motion has already started. The motion has taken place even before we started the actual observation. Now, after following, after watching this much, if you feel that after this is too much, if you're like, I don't want to learn simple harmonic motion, this chapter, leave it right away. Don't spend much time on this. But if you like, I've got some idea or maybe a bit of clue about what oscillation is, what phase is, that was the purpose I intended here. The purpose is not to explain phase in detail. Trust me, we have very detailed solutions, animated sessions, and interactive questions that will help you understand phasing better when we discuss oscillations and waves in detail. Not here. So the purpose is just to give you like a like a taster session, just to give you a bit of a glimpse of what oscillations in wave look like, and that the graph here, phase and time, doesn't come out of reference. It is very much relevant, in fact, significant when it comes to not just to motion in a straight line, but also to other chapters as well. Now, as we go to the second graph, we'll come to we will come to the realization that although the question appears to be printed in textbooks as motion, a question from motion in a straight line, it is actually covering 2 to 3 chapters, and therefore it becomes important not just for the JEE mains, but also for IIT Advanced. And that is why the JEE Advanced, the IIT level questions, and that is why we are spending this much of time here. Okay. All right, thank you. Now let's move to the next graph, which is a velocity displacement graph.